Are you in Mr. Eng's math class and have missing assignment and don't know what to do? Well, I have the answer for you. Just do these.
Hey guys, it's Mr. Eng. Let's go over the Module 2 test, February 5th, 2026. This is version 8. Multiple choice. Use the check marks the correct answer given the following graph. Point Q, question number 1, or 1, 1, is here. This is on the y-axis. Number 2, from point O to Q. So O to Q. We're going left to right. It is increasing. It's going up. Question number 3, point Q or S is a local minimum of negative 2.25. So that is a y value. So maybe down here. So you have either Q or S. S is negative on the negative numbers there. Okay, the function has how many zeros? So this just refers to x-intercepts or roots. So 1, 2, 3, 4 is our answer. And does the graph have even or odd or neither symmetry? The answer is even, because you can fold it in half. Even leaves my... Remember, this one would be rotated 180 degrees. Symmetrical about a point, the x about the origin. Remember my silly phrases, that's odd. Symmetrical about the origin, and then neither would be not, even, not odd. Okay, number 2, complete this sentence. What is the end behavior of f of x equals 3x to the 8? So this is called a power function. Just means it doesn't have a train behind it. And what you need to know is that this is a even degree. And the easiest one that we know is x squared. So that just looks like this. The arrows are pointing up. Now, the 3 is the leading coefficient. It is positive, which means it's going to stay there. Okay, so this is, let's draw a graph. Something like this. So this is the y, or f of x, and these are positive numbers going up, down, and to the left, and to the right are x values. So as x goes towards positive infinity, so as we go towards this direction, what's happening to my graph? Well, the y values are, it's going up. So that would be here, positive infinity. So that would be A is our answer. As you're going to the right, the graph is going up to the right. Okay, so let's do our Ken here. We have to use the numbers 1 to 4, and they're only positive. I'm going to look for the freebies, which have no math operations, so I'm very happy for those. 3, here's 3, here's 1. Okay. So I need 2 numbers that will add up to 3, and I would have to use 1 and 2. Well, I can't put a 1 here because it would be repeating with the 1 below in pink. So 1, 2. Okay, that means that this number will have to be a 4. So that now cage has to, 4 minus something will equal 1. Well, that has to be a 3. That gives me a clue. Well, this is missing a 2 in the column in orange here. And then 2 numbers that subtract to be 4, so this number has to be 4. And then I can, missing a 1. And then 1 plus 2 equals 3. And then we're missing a number here, 4. And we're missing another number 2. And then we're missing a 4 up here. And we're missing a 3. So 4 plus 3 is 7. Okay, use the function f of x to complete the following. They want to know what the degree is. The degree has to be the largest degree or exponent. And so the answer is 5. Now, this is not in order. So if you want to write that in descending order, you would write it by the power or exponent, the little number on the top right. So this would be written in descending order. Let me just point it out to you. We're just focusing on that number. Okay, so that would be descending order. And that way you can easily identify the degree, which is a small number. Let's go back to green. So that would be this thing. And then where's my colors? Down here. Then if you needed something, this would have been your leading coefficient. Not 4. Okay, number 5, use the table of values. So when I'm given a table of values, I like to just graph it right away. Just graph it. Okay, -1, -6, so it's down, so something right there. 0, 5 is positive. Just mark 5 there. Helps me just future, if I need to graph something in the future. Okay, 1, 10. So up there, that's 10. And then I got 2, 3. So still positive, but lower. A bit darker. And then I got, no, that was orange. Let's graph this. 323, right 3. And then down -22, so some way down here. Let's get your graph here. So I got something looks like this. Okay, so in this problem, they want to know what a relative maximum is located. So a maximum is a high point. So that would be my pink one, which would be x equals 1. So that pink one right here, this is a high point. Okay, a polynomial, number 6, has a base with a variable like x, and then the powers, or the exponent, this stuff here in the box should be whole numbers. So then it's not a polynomial, so pink for red, not. If it is a negative, no, if it's a decimal, negative number, if it's a variable, like a letter, and then you can't have, your base can't be, if that was a number, that would be bad. Okay, so let's take a look. Number 1, 6c. Now you can write this one, that's okay, because that would just be -1/5 m squared, and that's just a coefficient. We're not talking about 2, which, so this one would be a polynomial. Okay, that's what I'm talking about. That's the fraction. Can't have any fractions. It has to be a whole number. Okay, that's your list. Fractions is bad. Not a polynomial, so B will be our answer. Okay, which of the following is the simplest form of the expression? Okay, number 7 there in blue, I'm going to rewrite. And I'm going to stack them. And I moved that 4 way over there because I realized that 6, 5, 3, so I guess you're missing like a 0m squared plus 0m, and then over here you are missing a 4th degree polynomial. That's an m, okay? And then this pink one I have here, so I'm just going to line them up. I'm going to put a 1 there because it's missing a, oh, it has a coefficient. But here's the hard part. Let's do an orange. You have a negative sign. Oops, orange, negative. So what I'm going to do is I'm going to keep coming back to this negative sign. 8 minus 3 is 5. So this one, not that one. Okay, then I have 2 minus negative 5, which would give me 2 plus 5, which would be 7m to the 5th. So, here and here, not these two. Okay, and then I have, pay attention, negative 6 minus negative 1. So that would become negative 6 plus 1, which would give me negative 5m to the 3rd, which would be that one. So it would be this one. C is your answer. Now, you could have just distributed the negative and then do the same thing, right? So all the signs will change. And then you could have added this white here to the blue, but still get the same answer of C. Let's go to the back side. Okay, we're supposed to expand this. You can just quickly make a Pascal's triangle. And remember, you have your nth power here. And so if you slide down, you're going to get to this one here. So those are my coefficients. Let's write it down. 1, 4, 6, 4, and 1. This is my A. That is my B. So I have start with the 4, A to the 4, 3, 2, 1, 0. Then my B value, pay attention, is going to be a negative 3. B0, B1. Remember those values, right? These two values are always adding up to that number. Do you see that? So make sure that your exponents are correct. Okay. A common mistake for students is on the substitutions. They're not using parentheses. So I have 1a is 2y to the 4th power. Let me just do all the whites, do all the oranges, so this would become 2y in parentheses to the 3rd power. Okay, my b value is negative 3 to the 0 power. Notice how the negative 3 goes inside the parentheses and the exponent is on the outside. That's a big deal. Okay, so this one here in pink means 2y 4 times. So when you multiply that, you get 16. So this here under pink, 16y to the 4th power. This one in blue, anything to the 0 power is 1. So if you multiply those, you get 16y to the 4th power. Okay, let's go through all of these. Okay, so this is going to be 2y to the 3rd power. So 2 times 2 times 2 is 4, 8, and 8 times 4 is 32. So I have 32y to the 3rd. And then here in blue, this one's going to be negative 3. You have negative 3 to the 1st power is just negative 3. So then when I multiply 32 times negative 3, I get negative 96y to the 3rd. You'll notice I have no more a's and b's, and there's no x's here. Let's keep going. Okay, so that would be 2y times 2y is 4y squared. 4y squared times 6 is 24y squared. Negative 3 times negative 3 is positive 9. So then 24 times 9, this is going to be a positive 216y squared. 2y to the first is just 2y, and 2y times 4 is going to be 8y. Negative 3 times negative 3, write that out so you can see it. That's going to become negative 27. And negative 27 times 8 will give me negative 216y. Okay, anything to the 0 power is 1, so all of the orange is 1 times this one, so I have 1. And negative 3 to the 4th power is 81. So 81 times 1 gives me just positive 81. And that would be your answer. Now, a couple of you multiply this out. I'll give you partial credit if you just said, 2y to the 3rd power, there's 4 of them. Some of you guys are doing this, which is fine. And then this would look like this as yours. And then your answer would be a trinomial times this trinomial. And then you would just put it together. By multiplying it by this. Whoops, missed a box. Right, your white's on the side and orange on the bottom, and you should still get your same answer. Okay, number 9. Determine the quotient. Write the dividend as a product of the divisor and the quotient as a remainder. Okay, probably the biggest thing you should recognize first, and this 1 out of 3 students probably got this wrong, is you're missing a term. And so I put a little arrow, so you should have 2x to the 4th plus 0x to the 3rd. Okay, let me show you guys how to use synthetic. So this one I'm going to set equal to 0, and I get x equals negative 3. So that goes on the outside of mine. And then all the coefficients, 2, 0, negative 17, 2, and 2. 2, 0, negative 17, 2. You're just going to drop down the first one, and then you're going to multiply, add, multiply, add, multiply, add, multiply, add. Okay, so this is your remainder. That's positive over the divisor. And then this is your constant. Then you add an x, so that's your linear. And this is your quadratic, and then that is your cubic. So you could just multiply this one times the divisor, x plus 3, and then that will equal the original problem. So let's try to write that in blue. This one is thicker. This is your answer. Okay, let's try now the box method. And the box method is nice because you actually don't need the placeholder, the 0, but it's just helpful if you have it. Okay, so let's just draw our box. And I'm going to go ahead and use the divisor, x plus 3 on the outside. What goes in the top left will always be the first term, 2x to the 4th, and then you have to come up with stuff on the outside. So this is going to become 2x to the 3rd. And then 2x to the 3rd times 3 will give me 6x to the 3rd. Okay, so how do you get the next box? How do you get this diagonal right here? Well, notice it's cubic, So it would have to be equals to 0x to the third. Okay, so let me write it this out, this might help. 6x to the third plus something equals 0x to the third. Well, that's going to be a negative 6x to the third. And then you do the same process of what's on the outside. Let's change colors. So that would be a negative 6x squared and negative 18x squared. Okay, so same thing. Let's pick another color. We don't have yellow, huh? Let's try yellow. Okay, so these two are to the power of 2, and so it has to equal this one. Right? So I have negative 18x squared plus something equals negative 17x squared. That means this one will be a positive 1x squared. Negative 18 plus 1 gives you negative 17. And then you just start your process again. So this will become x, that will become 3x. And you're going to make that equal to this one, so that'll be a negative 1x. So then I have negative 1, negative 3. Okay, once you get to a constant, this is your remainder. Okay, this last box, you're not going to use that one. So negative 3 plus something will equal positive 2. So that'll have to be 5. Negative 3 plus 5 gives me a positive 2. And so that's your remainder, is the 5 there. And then you can write your question just like you did above using that. Gives you this. Okay? So 2 methods, choose which one works for you. Okay, number 10. F of x has real zeros. So real zeros just means it crosses the x-axis at negative 2. I'm gonna make mine a little bit bigger, so you don't have to do this, but hopefully it's a little bit easier to see. 0, 1, 2, 3, 4. Okay, so I have negative 2, 0, 2, 4. 0, 2, and 4. There are my 4 real zeros. Okay, as you go towards the right, you want to go down. On the x-axis, as you go towards the right, f of x values go down. So that's my x. This is the y. So as you go x positive infinity, negative means you go down. So as you go right, you get down. Okay, this one says as you go left, you go this way, what happens to your graph? Well, it's telling you it wants to go down. So that's why I'm having here. Okay, so let's just make this super clear. Negative, negative. They're both negative, negative. Okay. Okay, so we got our real zeros. We did the end behavior, which just tells us where the arrows are at. Now let's do this part where it talks about increasing and decreasing. So this is integral notation. It's increasing from negative numbers to about negative 1. So I'm going to draw this one right here. So basically my graph is increasing to that point, but going through that line. Okay? And then this one is decreasing from 3, so I'm just going to put a boundary there. We talked about using vocab words and decreasing. So from there on, it's decreasing. So let's draw the rest of the graph. Let's pick the color. Red. Okay, from there, we need to go through this point. Doesn't matter. Okay, so from purple, that I need to start decreasing, but go through that 4. Goes through something like this. Okay? So there's my graph. Let's color this one. This is purple. This portion is decreasing, going down the roller coaster. Hopefully that was helpful. See you guys. Bye.
Gather around, let me tell you about Mr. Eng. He's the math maestro, got that stat slang in the classroom. He drops knowledge bombs, equations flying like beats, setting off alarms.